Hey guys, can you hear me? I hope today worked. If you are on, just please say something or just say hi through this chat. Um, I'm gonna wait until 8 o'clock and then I'll start our lecture here. Okay, so please hang on and I'll be back shortly. Let me go to my iPad and then double check on this live stream again to see how the quality goes. Okay, all right. I'll be right back. Wow, I think it's great that I think now I figured out last Tuesday. I think a few mistake that I think at least two. One is I connect many Bluetooth device, so therefore I think it just kind of mess up my audio. And the second uh, mistake is that I used to test live broadcast on YouTube. I didn't do the schedule, but then once I set up the schedule live broadcast, then I had to go to the studio and then click go live, and that's why some of you guys didn't see anything at all. So let me do this. Let me just test my iPad and see and hear how my audio I think is being broadcast. Can you all hear me well? Well, I'm back. I think we have 3 more minutes. Right now it's 7:57. I noticed that when I checked my um, on my iPad on whatever this live stream is maybe a minute or half minute kind of delay. So if uh, any of you guys have any issue hearing or have any question, please feel free to let me know. Okay, so don't be shy. I think this is a the kind of a challenge situation. I think we should take crisis to be opportunities. I'm also learning how to use all these technologies. I mean, if you ask my personal preference, I would prefer to teach in class. I mean, so good, 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 good. I think you can hear me well. So, but anyhow, I think let's work together in so that we can get out of this situation. I think everyone, I know that I think you have some concern, but anything that I could help, you want to talk with me, so please feel free to contact me. I mean. Maybe using Skype, email, or anything, or even you want to meet in person. I'll make the trip back to on campus. I mean, right now we have been instructed that we should be practice social distance. So I'm at home by myself, but you can contact me anytime. But anyhow, I think maybe let's get started. I see we have around 17 or 18 person that watching this YouTube live. And again, if you have any question, I mean anything is not clear, please just let me know by using, I think the best way is using this chat room. My colleague used different type of teleconferencing kind of tools like Zoom. But I'm afraid that once we have the participant or the student more than 30 plus, I think we're going to have some issue in terms of the bandwidth or the scalability of the system. So hang on, and then we'll use this YouTube live and so that I think we can learn together. Okay, I'll do my best in my ability to help you out. All right. So let's get started. Okay. Let me just switch to my start screen here. Um, well, I mean, let me just repeat on the class info. Last time, the record, whether video that I have upload. If you, listening or watching my previous video, you see that we now we're gonna conduct our class through this live stream or online. I think the good thing is that once you do this live through this YouTube live, I think you have video record. So in case that someone want to repeat, you can go back and watch the video again. Okay. So make sure that you check Moodle before every class meeting. I'll try to provide all the links, to useful information as much as I can, including the URL to the live stream, including the material, the class material like the PowerPoint. So we're gonna conduct the class. During our regular time from 8 to 9:50, and I will practice the same way that we do in like face-to-face meeting by having 3 to 5 minute break in between. I think 2 hour long or hour 50 minutes. It's quite long. Both for you guys, student as well as professor. My office hour is gonna be regular office hour that I have posted, so I have not changed. But instead of meeting or I would be in my office, you can contact me and then we can do video conferencing through Skype. I have not seen anyone add my Skype name, okay, which is NAIBOX. If you search for this screen name, you should be able to locate me, and then just add me as whatever your contact. Okay, so then if you want to talk to me 1:30 to 3:30 p.m. Monday to Friday, I'll be available to talk to you, otherwise by appointment. The email, the preferred email would be naibox@gmail.com. Please use it. Okay, do not use LaTeX email, because I read LaTeX emails, but then there are a lot of junk mail, a lot of whatever the other unnecessary activities, I mean, that channel to LaTeX email. So the Gmail, I have a way to filter and then gain some attention there. Also, the first time that I provide my personal cellular phone, in case that you want to contact me or talk to me, my number is 318-243-6597. Please text me before you call me, because normally I don't pick up the call if I don't know that phone number. Okay, and by the way, don't post my phone number to the public. All right, let me check with you all again. Can you all hear me well? Can you do me a favor? Just I mean, type a short message to say that, I mean, you hear me okay. All right, before I proceed. I don't want to keep talking for hour and a half or 2 hours, and then, I mean, you can't hear me, or there's some poor audio there. All right, so I will monitor the chat and then see, whether there's some question or anything else. Okay, so let's move on. Now, the important dates. Okay, I think I like to gain your attention. Initially, we didn't plan that we're gonna, I mean, go through this COVID-19, shut down the campus, but it appeared that, and I think my hunch, we're gonna probably have to do online for the rest of the quarter. I mean, I may be wrong. I hope that I'm wrong. Okay, that we can resume a normal face-to-face meeting. But I suspect that we probably will have to continue on, so that we can fight this COVID, because I think the most effective way to fight this COVID virus is just a social distance, or meaning that don't spreading this virus. Okay, um, so therefore, the midterm exam and final exam, I decide to scrape off, but I will add 5 to 10 quizzes. Okay, throughout the whole quarter. So every week or 2 weeks, I can have a quiz, and then quiz will have some due date. So please monitor and make sure that you take the quiz and then get your score. Okay, because otherwise it might impact. I think your grade. So please working together. And the reason why I have more quiz, so that I would have a shorter time feedback. So then I would know whether you're with me or you're lost, or whatever reason, okay, that prevent you to learn from out my class and other class. Okay, the term paper presentation, I still keep it there. I mean, initially I kind of hesitate to see how would we do a term paper presentation, but then, I mean, as I told you, use crisis to be opportunity. Then you can learn how to video yourself, either, straight record from your cell phone, or you can use your computer and then use some tool broadcasting like OBS or different other tools that people using as YouTuber, whatever those game broadcasting. Okay, so in terms of term paper presentation, it's gonna be the video presentation that you would have to upload and then send me the link. Okay, so the due date still remain on April 28th. Okay, all right, and the revised grading policy, as I told you, the term paper presentation or the YouTube type of video is 5%. To programming assignment would be 20%. Okay, which is the same, and then to homework assignment is 10%. That are written assignment. Okay, and then we would have 5 to 10 quizzes, either every week or every other weeks. Okay, and that's constitute as 25%. So roughly each quiz is around 8 to 10%, roughly. If you guys have any question, comment, suggestion, so please feel free. Okay, feel free to just give me some feedback. I mean, here we are together. So anything that I can make you or improve your learning kind of experience, please let me know. As I told you, um, this is my last year and a half. So all I want to do, I want to see you guys being successful. Okay, so be with me. All right, so continue on. So let me recap. Okay, last 3 or 4 lecture, we went through introduction to operating system. But in fact, we talk about what is operating system. In fact, operating system is just a system program that sit between user and hardware. Okay, and then this system program that perform as user interface, perform as resource allocator, resource manager or management. Okay, that allocate CPU cycle for you, execute your program, allow you to access certain device, let you use application so that perhaps you can use browser, YouTube or whatnot. Okay, those are things that operating system support. So the main goal of operating system is provide user interface to the system in more convenient, efficient, and secure. Okay, it's also provide an ability or feature to execute user program, make solving user problem easier. Okay, so these are high level type of system goal. Okay, but as I mentioned in previous lecture, different system, nowadays most whatever system that you use are computer control, not just computer, the device that you use, the whatever HVAC, the lighting and all those kind of things. I mean, things getting smarter and smarter. So therefore, there are a lot of situations that people need to execute program. Maybe program on your watch, program on your desktop, program on your little device. Whatever computer control smart bomb or whatnot. Okay, so different situation, different requirements. So therefore, there's no one size fit all. Okay, as you see from this slide, all these devices that I show you on this screen. For example, traditional computer, or your desktop or notebook supercomputer like the Titan on the bottom middle. On the left hand side, you have car that some of the car that is fully automated, such as a Tesla. Some of the modern car can drive by itself. So in that case, it must have some sort of computer system with operating system running software to detect, sensor and everything. So then it could navigate. Refrigerator, smart appliance has some sort of application running on those, and application running on those, basically it has to go through operating system, because without operating system, develop application on those devices could be quite difficult. So I think the next chapter we're gonna talk about, we'll talk about operating system design, structure, and the protection of operating system. Um, any question, again, feel free to type on YouTube. Okay, all right. Well, I think when is I saw the question. From Jack. When is the first quiz? Okay, or homework? The first quiz I probably anticipate sometime mid of next week. Okay. Normally I would like these lectures is already on the Moodle, Isaac. Okay. Let me answer the first question first. Okay. So the first quiz or homework, I would say the first quiz would be middle of next week. Normally, I like to do at the end of each major lecture or chapter. However, since we still adjusting with this online learning. So I give you a little kind of extra time, to maybe perhaps for someone who have not get on the video, you can start, watching the video. Okay. So basically, the first quiz would be sometime next week. Okay. The second question is, can you post the lecture on the Moodle? I already post the lecture on the Moodle. If you cannot not access, okay, please let me know. All right. Okay. So let's move on to whatever the next thing. Okay. So I think previous slide, as I show you, we have a various system or hardware that it would touch upon our life, whether it's traditional computer, desktop, or notebook, all those devices, the car, the refrigerator, the crock pot, the rice cooking system, washing machine. Some washing machine is IoT device, or you can control, via, the app. Okay. So with that, some of those equipment or machine, it require some form of operating system. This slide show you various type of OS, maybe the same. It classified as one type of OS like Linux. Okay, but Linux has variety of distributions such as CentOS, Fedora, Red Hat, SUSE, Linux, Debian or whatnot. Okay. Also, but then on the top, if you see all those icon, those are major operating system. That on the left hand side, window, on the middle is Mac type of OS that include Mac OS and iOS. In the middle is Android, and on the right is Linux. Okay. So variety of operating system. Why? Because different situation, different system has different needs. Okay. um, so to recap the chapter one, the introduction to operating system, type of question that I could ask you, such as please identify what are important resources or features that operating system must effectively manage for the following system. For example, the desktop or notebook. Normally, the current desktop or notebook, you have to have a screen or graphic user interface. You have to have mouse and keyboard so that people can interact, can use your computer, issue or writing program. So graphic user interface is quite crucial for the desktop. Um, and then the rest like CPU management, memory management, file management, those are a common important feature that most system must have it. Okay. The second type of example of the system that I asked to identify what important resources or feature that OS must be effectively managed. The smart bomb. For example, smart bomb, if you heard about Tomahawk, okay, smart bomb is a real-time system, and normally is it's used for mission type, critical type of environment or situation. So therefore, it must use hard real-time system in a way that it must guarantee, the completion time of the task. So, for example, if it's supposed to calculate the trajectory and then calculate the accuracy, how to hit the target. Those tasks must be guaranteed to complete in order to launch the mission. Okay, so smart bomb, the real-time system, task completion time, I think is critical in order for operating system to manage. The next example of the system that I think most of you guys have, which is mobile phone or smartphone. As you know that mobile phone and smartphone, you don't have power plug in all the time because you travel, you move around with your mobile phone. So therefore, power management with operating system is very critical. Okay, so that you don't have to charge the phone all the time. Last but not least, example of parallel system or supercomputer. I think from our previous lecture, I show you top500.org. One system, the largest or the fastest system called Titan. Nowadays, it got 2 million something core that build of 50,000 or 40,000 nodes. Okay, so it built from the building block. So in that case, it has a node concept that as the building block, and then you can cluster them. Okay, make as if a supercomputer or large scale system. So therefore, node management and network management is quite crucial in order to manage, distribute the tasks, add the node, delete, change the node, add new network or whatnot. Okay, so these are sample question, to validate your understanding from the first lecture, which is basically introduction to operating system. Show you historical aspect, various system, how system work or require for certain tasks, and therefore you may have a special feature of operating system must be support, okay, in order to make those systems work well. So I think that is the recap from what we have discussed last week, which is lecture 1. Now I'm gonna continue on lecture 2 or chapter 2. Okay, if you have the book, it's not exactly 100% identical to the book because I'm adjust some content based on what I have seen on my experience in the past 20 years. Okay, so I include the concept of operating system design, which translate to structure or architecture, and also I touch upon the protection that operating system has in order to ensure that a user will use the system in more effective way, secure and efficient. Okay, so the topic in this lecture 2 or chapter 2 would be list here as follow. Okay, so I think we're gonna start off with the concept of operating system layer or structure or the design, and then deep dive into important services, and touch upon user interface, system call, and various things. So let's get started. Um, the operating system design or structure, okay? In fact, as you know that operating system is a system program. It's just a special program, okay? This program, as you know that people wish to use, to develop the program that very robust, very efficient, okay? So in terms of software engineering, it makes more sense that we can break down, the big system, okay, into layer or into modules, okay. So most modern operating system, okay, structure or architecture or we call design, okay, is a layer approach, okay, which is similar. Sometimes they call ring approach because if you see the ring on the right hand side, the diagram, if you cut the ring in half and unfold it, okay, it's gonna look like layer approach, okay. So in that case, underneath it or the bottom of this layer approach obviously is the hardware or the system or the device that you want to manage, and then on the top of the hardware you have kernel, okay, which is a main piece of operating system that running all the time, okay. And then within this kernel system, you can break down into subsystem or modules such as process management, memory management, I/O management, okay. And then on the top of the kernel, you have the interface between kernel and user. Either you access all these system resources or service via system program that the user can type the command and then use all those commands directly, or if the user is become programmer, then that programmer will write a program, and then when the program if the program execute a normal instruction, those normal instructions going to be executed on CPU. So in that case, there's no special kind of treatment on those, except once your program get execute, it will allocate operating system will allocate CPU cycle to run on those software or normal instruction. However, sometimes the user program may want to access certain system resources that provided by operating system. So only the channel that the user application can access the system feature is through system call, okay, which I think all of you guys assume that you guys learn from your CSC 222. Okay, so we're gonna talk about those system program system call a little later on. So with that layer approach, I just want to quickly show you the actual operating system that follow those concept or layer approach. The first example is Linux kernel or Linux structure. As you see that it divides into three major parts. On the top is the user space or the user level that the user can interact either through system program or user program or uh, um, whatever system call. And then underneath it is a kernel level or Linux kernel level that consists of the subsystem. So as you see that the layer approach within the layer is also broken down into subsystem such as process management, CPU scheduling, memory management, inter-process communication, file on the left hand side of Linux structure, which is file system that not only to be used for manage all your storage or file management, but also it can be used to manage various devices. As I mentioned before, to uh, uh, to access your file, you probably require four major operations: open, read, write, and close. Okay, you may have different additional kind of operators, but these four major operators are important or major operators in order to access file. However, all these four operators, you can also access any type of device, because to be able to use the device, okay, then you can open the device driver. And then after that, you get file handle back, and then you can write or you can read. By saying write, if you want to send the data to the device, then the write command would give you ability to write, or if you want to send the command to tell the device to do certain thing, those data could be command by itself. Now, if you want to read the data back from the device, you can use read operator as file system use, or when you no longer use this device or the file system, then you should close the file, okay, so that it will let other user to use, because sometimes if you open file for read, then there's no big deal. But then if you open two file channel for write, then you're gonna facing some headache, because of it's very difficult how to have to write kind of stream into one file system. So I think let's move on. We're gonna talk about this a little later. I mean the main reason that we talk about, or I'm showing you this Linux structure, just trying to give you some feel of the real implementation of the operating system structure or layer approach. Now, this is just another example of Android. You can see the layer approach. In fact, it adds on different other layer, including application framework, including telephony kind of subsystem or whatnot. But still, it's the layer approach. And the benefit of this layer approach, that means you don't have to do a big bang type of development. That means you can start, incremental by start from the main or the platform, and then you can start add on one module at a time. And this is window. I mean, if you look carefully, it also layer approach with modular design. Okay, so essentially, most modern operating system have a similar structure or concept, which is either modular kind of approach or layer structure. Okay, so the benefit of the layer architecture or operating system architecture layer approach is easier and then provide incremental development. That means you don't have to just develop the whole thing, everything in one shot. In fact, develop the whole thing or a large scale system is done difficult. Okay, and then it's also give a lot of constraint on staffing and also testing different other activities there. But then if you can start add bit by bit, okay, start from the foundation and then adding one module at a time, okay, so in that case it would help improve whatever the manageability. It provides an easier way to manage develop test and deploy. Okay, so therefore it enhances reusability and it's good for software engineering aspect. uh, Let me quick check on your comments. Okay. Okay. All right. So I think so far so good. Let me just move on. I just kind of switch screen and see anyone has typed any comment or not. Are you all okay? All right. Okay. Let's move on. So now I think we discussed about the operating system design layer approach, but now let's talk about features, or we call operating system services. Okay, main feature of operating system. I mean, we probably uh, must start off user interface, as we have given you definition of operating system. Okay, it's the system program that allow user to interact or to interface to the hardware. So therefore user interface is one of the most important aspect of operating system. Nowadays I think long time ago when first operating system come out, okay, there's no mouse, there's no keyboard, it's all command line interface. That means you have terminal, just like I mean, if you have Linux terminal, or you have just terminal there, which is 80 by 25 characters, and then you have keyboard that you can type command. Okay, so but nowadays I think from 1980s, okay, graphic user interface start become a mainstream feature of operating system. Okay, but later on I'm gonna ask you who invent graphic user interface. Okay, and past 4 or 5 years, voice UI or voice user interface, such as Siri, Alexa, Google, whatever, I mean, voice kind of things, okay, start become increasingly kind of popular. Okay, I mean, especially a lot of situation. I mean, if you ask me as the programmer, I would still use keyboard and mouse. But then as the end user, when I start driving somewhere, okay, sometimes, I want to acquire certain information. I mean, going to type something is quite dangerous. So voice command, okay, that will translate from voice to text and text to command. And then eventually it will interact with the kernel, execute some program, and start providing us some result, or whatever we want to achieve. Okay, the second type of important system service or operating system service is interface or API. So from user interface perspective, operating system also provide system feature, provide system call that allow not only user but other program to access um, system features. Okay, such as I told you, process management. In fact, the third bullet list is program execution, and in fact program execution essentially is process management. Operating system allowed user to execute the program by create a process, okay, and then load the application binary or execution and running on those process. Okay, so in that, the system operating system must have an ability to load the program in the memory. So that imply memory management. Okay, and run the program, execute the program, and the program sometime, if it execute normally, then it will complete it, so that it will give the status, and then the user would know yay or nay, or positive or negative. But sometimes some program, some application may have some error. So therefore, operating system must have some ability to do error detection and error reporting. If you guys remember, I think especially in my class 222, toward the end when we did system call, I think we have gone through, error handling and error management, using the information that called error node in order to find out what type of error, and then we can go fetch human readable error message. Okay. Now the next feature is an I/O operation. Okay, so that's part of because of computer or hardware. Not only it has CPU, it has memory, but also it has some device that you want to communicate or send email or do something. So therefore, operating system has a layer. Normally all this IO device or operation, it wrap around those device, okay, or it's a gateway or operation to manage or access all those devices, okay. When we have time, we're going to talk more about the device driver concept, okay, which is a little piece of the kernel code that attached to each device, okay. But then on the top of each device, it has virtual file system, which is an object-oriented kind of API that provide common interface to any type of device. But then when you open certain device driver, then it know how to find the right executable on that particular device. So don't worry about the device driver. We're going to talk about later on. Another important feature is file system. Imagine that if you don't have file concept, how would you store your data? How would you listening to your MP3? How would you watch the video or whatnot? How would you record? How would you buy whatever the e-commerce? I mean, so file abstraction has been invented. I mean, probably more than 30 years, but still, remain very current, very classic type of abstraction, okay. Typical operation of file operators or operation including read and write, but before you read and write, you must open, okay, in order to declare that I'm going to use that file, okay. And then after that, you can do operation, normal operation, read and write, okay. And then once you no longer use it, you just close it, okay. So not only read and write, but also sometimes you want to create not only file but directory, okay. Directory you can think about is a collection of the file, okay. Later on in chapter 9 or 10, we're going to talk about file management and directory management and how directory is implemented at the file management level, okay. And then other operators or operation with regarding to file system, it allows you to create, delete, change list file information, and then provide permission so that you can protect your own file, or you can open certain file for your group or your friend to read, okay. So I think some of activities that we did in 222, I think all discussion on file permission. You guys remember 9 bits: read, write, execute, read, write, execute, and read, write, execute, okay. Those are for file permission that I think at some point, maybe chapter 9, we're going to talk more about this, okay. So I think right now let's talk about a high level operating system feature or service. Beside user interface, beside system called API, program execution, IO operation file system. It also provide communication mechanism, allow process to communicate, okay, and also support an error detection and error handling as well. In terms of error detection, operating system need to be consistent, aware of as many as possible errors, okay. So it got a list of handful error cases that it can handle, but then if it cannot handle certain error, it's going to be catch all. So in that case, I think operating system would provide the best possible error message so that the user would know what's going on. For example, if you run into low memory errors, okay, then if you are the system admin, then you're going to go and check the system to see whether the system is overloaded or not. So then you can do certain things. So error detection and error reporting is quite crucial in terms of manage, especially for people who manage the system. For people who use the system, I think you would have indirect effect where the system may be slowed down or the system would be outage. So therefore, error detection and error recovery, error reporting mechanism is quite crucial. Any questions so far, guys? I mean, if you guys have any question, please feel free to type something. Are you all still awake? All right, okay, so let's move on. Not bad, I think I saw 21 of you guys currently watch this one, even though I think we have 37 registered for this class. So I hope that if someone cannot watch for live, I hope you guys or you tell your colleague to watch the video later on, okay? Because the quiz will based on the content that I present, I mean, via this video. So, all right, okay. I think beside that, I mean, in general, as I told you, operating system is resource allocators, okay? It's allowed, I mean, the user to use whatever those resources in more um, um, fair ways, okay, or more efficient way. Okay, so CPU cycle will be allocated, memory management, file management, all those kind. And last but not least, some operating system, most operating system, you can turn on accounting, meaning that it would keep track the usage of system resource, whether the CPU cycle or the file storage and all those kind of things. If you guys want to know more, for example, the usage of the system, I mean, there are some commands such as tops or different other commands. So let me just quickly, show you the top command, okay? So if you execute, I mean, let's say that if you have this Linux or Unix terminal, when you say top, now you can see that I mean, on the top 5 or 6 line, it gives you a summary of your system resources or system status. Okay, so in this case, it said that I have 413 processes, okay, active, okay, and 3 or 5 running. As you see that this process management will swap in and out, and as you see that OBS, which is the first process, PID is 13953. Okay, OBS is whatever the streaming studio tools that I'm using. So it make use of heavily use of my CPU, 91%. Okay, and then you have any others process that listed. But basically, normally in your desktop, you have 3 or 4 process active. So therefore, there are some inactive process, even though it's still running, but then it may be in sleep mode, okay? But then you be ready to switch and then use some of those process. Some process maybe utility process or daemon process that running on the background. For example, if you notice that you see my Dropbox process there, even though I don't run Dropbox, but then it listening and then checking to see any change to my file system. If it's so, then it would trigger the synchronization. Okay, so I think but by the way, when we talk about accounting, in terms of accounting, if you want to aggregate number of CPU usage, okay, then you can take the snapshot of this CPU usage of each user. You can see PID. Once you be able to identify PID. You guys remember what PID is? PID is process ID. Every process has process ID, and then each process has the owner. So in that case, you can aggregate the total number of usage in terms of CPU, in terms of I/O, in terms of disk storage or whatnot, and then create the report, okay, with respect to accounting. Okay, so let me get back to my PowerPoint. Okay, now, so I think last but not least, the modern operating system provide you protection, security, as well as privacy. Okay, so normally protection involved, I mean, an ability to ensure all access system must be controlled. Okay, all access to system resources must be controlled. For example, if you don't have permission to use certain thing, then you would not allow, you would not grant the access there. Okay, in terms of security, which is protection and security is go hand in hand. Then let's say if you want to use the system, log into the system, then it must be logged in and password protected. So in that case, it will require authentication and authorization in order to use the system. Or maybe you can do fine grain protection by manage every single resource. I think that can be done as well. Last but not least, not only protection, security, and also privacy, because sometimes you may want to protect, or you may want to control the access, but also each individual user, you want to protect your own information or data. So therefore, some system you may have some encryption, some access control list that would see who you are, which group you belong to, what can you use, what can you use, what can you see, those kind of things. Okay, so in general, I think most of you guys should know all these feature, or at least experience, because you are born in digital era. I think, as I told you myself, I migrate to digital era. The very first time that I start using computer is around early 1980s. Okay, but then that time some of you guys may have wasn't born yet. All right, so let's move on. Now, as I mentioned before, to access all these important operating system feature or resources. Normally, two channel that you can do so. One is through user interface. And then, as I mentioned, there are various type of user interface, such as command line interface, graphic user interface, or the voice interface. Okay, those are a direct access or direct interaction. Okay, that you can use system program to get, change the permission, create directory, do certain things. Okay, also as the programmer, when you write your application or user application, if user application want to access system resources, okay, then you can use system call. In fact, I believe that all of you guys should know what system call is all about, because before you take this class, you should take 222 before CSC 222. But then system call, it appear or look more similar to function call, but the specialty or the special treatment of the system call is this special function is controlled by operating system. So in fact, when your user application call system call, your user application process that run that application will get suspended. And then the control will control from user level to kernel level. And then the kernel, which is operating system, will execute system call on behalf of user process or user application, while user application gets suspended. And once the system call execute and complete, then it will return, but before it return the control back, it will wake up the user application process and then hand back the control and then the response or the result back. Okay, so I might ask you in the quiz or in the homework that what are two main ways to access system feature or system resources. Then you have to answer. One is through user interface, using system program. And then the second method is via user application using system call. All right. Let's take a look at each important operating system features. Okay. The first one is user interface. Okay. Even though I show you various kind of device, on this screen, some of those look kind of very antique or old, but during that time, I think that top of the line. Okay, in fact, on the left hand side is Apple II. Okay, which is an early Apple kind of desktop computer, okay, that Apple introduced by Steve Jobs and Steve Wozniak. Okay, and then on the right hand side is VAX or DEC, DEC, Digital Corporation. Okay, at that time is the top company just like IBM, or whatever the top hardware company, but then they got bought by Compaq, and I believe that HP later on buy Compaq. So in that case, they're all gone right now. But at that time, that is the command line interface that you can type from that keyboard, and then when you see whatever those like the tube TV, the small tube TV, that is the terminal 80 by 25 characters, which is mimic the terminal when you pop up from your desktop nowadays. And then on the below left, that's iPad, iPhone, and below right is voice interface through Amazon Echo. In the middle is an iWatch that you can just use your finger or hand gauge, or you can use Siri in order to command your watch, or you can twitter your watch with your iPhone, and then you can control your iPhone. So now, as I mentioned, I mean, the very first and simple user interface is CLI. I think you have to know the term CLI stand for command line interface. Okay. In fact, command line interface, as I think for all of you who has done 222 with me, you were asked to write a shell program. I think by this time you should know what is shell program. In fact, shell program is an interface that listening to user command and then interpret whatever what user type, and then figure out which command, whether it's built-in or non-built-in command. If you are Linux or Unix user, there are multiple type of shells, okay, or flavor of shell, such as SS shell, Bond shell, K shell, TCHS shell, Z shell, or whatnot. But most of shell basically it does the same thing by take whatever the user type, okay, as command, okay, and then interpret and then execute accordingly. The only difference among those shells, especially on Linux or Unix, is some special features such as command history and command recall and all those, but and cut and paste type of ability. Okay, as you guys remember, I mean, normally the shell is user interface. Then typically shell will understand several built-in command. What built-in command? Built-in command are command that operating system well understood and know how to execute in the current shell. Okay, in a way that if you spawn the new shell, it does not make sense to execute those commands because the result that you expect it should be applicable to the current shell. For example, commands such as cd, pwd, and exit. The beauty of non-built-in command that means user or programmer or system programmer can add any command as they wish. Okay, so anything that non-built-in command, all the shell does is, can remember, fork, create a new process, and then exec or load those program execution and run on that given process. That's all it does. Okay, but the responsibility from the shell of the shell developer is that if it run into error or issue, then you should be able to report errors. And you guys remember how to report errors from whatever the system call. I mean, if you are the shell programmer, well, I think if you have non-zero return, okay, which is it indicates that there's some errors there. Then you go check error no. You guys remember ERRNO, which is a system variable that store the error code there, and then you can use string error or different other utility program in order to map that error code into human readable errors. Okay, so this is CI. Okay, the next I think right now most of you guys in terms of user interface, you are familiar with graphic user interface. In fact, graphic user interface, the very first one was introduced in around 1970s, but then it get used in the mainstream in terms of operating system in early 80s. Okay, basically, the desktop has kind of springboard. The popularity of desktop has springboard in early 1980 or mid 80s. Okay, and then most the desktop, which is including notebook nowadays, it consists of either in the past, I don't know whether you guys still remember the mouse. Now we have this trackpad, keyboard, and monitor, and then you have a graphic representation to showing your window. You have window management or whatnot. Okay, and the differences between CLI and GUI, basically, I mean, the engine or underneath it is similar, but then the way user interface, as the programmer, I probably would still prefer CLI. Okay, maybe combination using GUI. Why? Because CLI you can cut through, you can use all the command that you wish. In terms of graphic user interface, it maps certain command into icon. All you need to do just point and click. So in that case, you are forced to use what they provide. But then if you use CLI, then you can do anything you wish. In fact, you can do whatever GUI does, CLI can do the same and then more. Okay, I'm not going to talk about more on a variety of the system. For example, in uh, Unix or Linux realm or world, okay, it has X window interface. Okay, in terms of Microsoft Windows, obviously Microsoft Windows has those window interface. Macintosh has Aqua graphic user interface, and Linux, beside I mean the X window as window interface, but also has slightly different desktop management, for example, the KDE or different other type of interface. I think I'm gonna go through a few more slides, and then I'm gonna call for the midpoint kind of break. Okay, do 3 to 5 minute breaks. Okay, but let me finish this graphic user interface first. Now let me ask you a question. Okay, just pretend that you don't look up or anything. Who introduced graphic user interface concept to operating system? I give you some hint. Okay, as I think I slightly mentioned. Okay, the first GUI concept was introduced in early 1970. Okay, by whatever the researcher from the company who also invented TCP/IP protocol. Unfortunately, I mean, this company didn't take, benefit, or didn't uh, kind of, acquire the patent of both TCP/IP and GUI concept. Okay, and then released into public domain. Okay, what's the company? What is the company name? Let me give you another hint. This company does something with papers. Okay, all right. Let me not delay you anymore. It's a Xerox. Okay, Xerox has a prominent research group called Xerox Park, which is in Palo Alto or in Silicon Valley, next to Stanford. Okay, so this is a very first Xerox graphic user interface. If you, Google to see Mac, okay, or very first Mac graphic user interface, they almost copy almost exactly just like this Xerox, okay, graphic user interface, which is invented like 10 years early than the commercial version that Apple has introduced or released in mid 80s. Okay, now let's switch gear. Okay, oh, why don't we do this? Why don't we take 3 minute breaks? Okay, and I think I'll 3 to 4 minute break. I'll come back or resume. Right now is 8:56 my time, so I'll come back around 9 o'clock, and then I will continue 50 more minutes. So guys, go get some fresh air or maybe a cup of coffee, and then come back and resume our lecture. Okay, any question, please type. Okay, I will try to read and then answer you before we resume, but otherwise, if I don't see any question or feedback, I will continue on. All right, guys, so take 2 or 3 minute breaks. Next time I should have some music stream during the halftime break. Otherwise, it's quiet. You guys might fall to sleep again. um, yeah, I have a breakfast tea in my Yeti cup here. Sometimes, I think even though I don't like this online or streaming because of I can't feel you guys. So I mean, please, even though I think you're okay. Um, if I do good job, just say so. If I do poor job, say so too, because so that I could try to adjust in a way that it will improve your learning experience. I think this is critical time. It's all kind of difficult, but we'll get through this. Okay, I'm pretty confident. All we have to do what we can control. For me, what I can control is learning the new tools so that I can deliver good learning experience to you, even though it's not my choice, not the best, it's not what I wish. But I'm take this crisis as opportunity. Now I'm getting there, I'm learning, I create different scene and then can switch to different other things. So in fact, the way I set up my broadcaster tools here, I can switch to any scene that I could show you different things. In fact, I start off before the live stream begins scene, and then I have the main scene that when I talk you through the PowerPoint, and then I have this be right back in order to kind of remind you that I think we take a break, and then I have the terminal scene so that I can switch to there. Um, the quiz. Okay, someone asked the question: How will we quiz take? Oh, he retract it. Okay. Well, the quiz will be on Moodle. Okay, so I cannot post, but the quiz has the deadline. So the quiz will be on Moodle. Okay. I have not done the quiz on Moodle yet, but I'll figure it out. I was told by my colleagues that quiz can be used Moodle to facilitate this. As I mentioned to you, we have many quizzes. So I don't want you all delay and take quiz at one shot because why? As I told you, your exam, okay, the answer of your exam normally would be the feedback telling me that whether you do well or you don't do well, or I suck, I don't teach well, or certain thing because I analyze based on the result from the exam. Okay, for example, if all of you guys but one cannot do one question, then that means it might not be my issue, but then that may be something that how could that student or individual cannot perform. So if the student don't come to the class, don't practice, don't do the homework, then I can't do that much. Okay, but then if that student attend all the meeting, listening to all this live stream, but cannot perform, that's mean my issue. That's mean if all of you guys cannot answer one question, that's my problem, not your problem. Okay, that mean I cannot deliver good enough learning experience to you guys. Okay, so now since we don't have face-to-face meeting, I can't feel you. So therefore I would like to use many quiz as mechanism to help me looking into checkpoint to see whether you follow me or perform well or not. I mean, right now, I think we have a little over more than half of the class, which is I'm really kind of, proud of you guys. Even though, very early morning, and then plus you're not forced to come to the class, still more than half, attend this live stream. I think that is very good. I hope we can keep this number. um, I don't want to kind of bribe you, Maybe I could use number of attendees or concurrent viewers to factor in the grading. Maybe the more, then, that can be a whatever the normalized factor in order to improve your. I don't know. So, but anyhow, that's joking. Let's come back. Let's resume the class. Okay. I hope I answer your question. I'm not sure. I think your screen name is kind of, I can't guess who you are, but you quite attentive, raccoon bro. So if you say hi to me and tell me or if you prefer me to call you raccoon bro, then I can call you raccoon bro. You can call me big cat bros too. I love big cat. So anyway, let's continue on. If you guys don't have any question, I don't see you guys have any thing typing to me or feedback, give me feedback except how the quiz can be done. Okay. As okay, let's continue on. I think we're still talking about operating system structure, and now continue on in terms of operating system feature. As I mentioned to you before, to access system services or important operating system feature, you can do through system call via your program, and most system call on Linux or Unix. Okay, you have to write your program in C or C++. Okay, thing that you can do via system call, including process control. What process control mean? Create, delete or terminate, or synchronization. Okay, you can do file management, device management, information maintenance, meaning you can acquire to see the resource usage. And then last but not least, you can perform some communication or inter-process communication. Okay, in terms of system program. Okay, which is as the end user or the user of the system. You will use either CLI, the command, run those system program via command line interface, okay, on your shell, or you can use graphic user interface that wrap around and map to those system program. So in that case, you can do similar thing that the system call provide. In fact, it's just a set of the same feature that operating system provide you two channel. One is through the system program that will execute whatever that underlie code or program to perform certain operating system features. Okay, so either use system call or system program. Now, next, let me see. Oh, Carrick. Okay, so I just saw something on the left of my eyes corner and see someone type in one. I will get off screen flicking when he's on the PowerPoint. Yeah, I think I'll figure it out, Evan. I think last time the first um, video, I think it crazily flickering. But then second video, I thought that once I don't overlap my OBS and my PowerPoint, or somehow the screen overlap, then it reduced this flickering. So if you guys have any suggestion, or you guys Google and tell me solution, I'll try to Google and find the solution to stop this flickering kind of effect. I think I know that it's kind of annoying, so just bear with me. I think we will improve your experience, incrementally one by one. Okay, so all right, so let's continue on. Thanks again, both Carrick and Evan and Jake. Okay, so we'll figure this thing out. So bear with me. I don't want to kind of figure it out right now. That may kind of mess up, the whole thing. So let me continue on and we'll see what happens next time. Okay, so apologize for this. Now, as I told you, is some sample of system calls such as process management. I'll show you for someone. I believe that everyone, even though some of you guys have not take 222 with me, didn't do the shell program, but you did some fork and exec, okay, and then have done some sort of system called homework, okay. So example of system call is this one, okay. Let me just trying to use the pen. Where's my pen here? The fork here, okay. This is the system call, and then this is another system call, and then this is another system call, okay, and then this is another system call, a direct system call when I say it, okay. So example of this fork.c, what it does is first it create a process. and then you know that if it return negative number, okay, that means there's some errors there. So therefore we should exit. So we exit with -1, and then do f print f to standard error. Why would we have to do f print f? You gotta remember, because f print f, it gives us ability to channel that messages or the printf into certain channel, and then the first argument of f printf could be file descriptor. So in this case we use stderr file descriptor, which is descriptor which number? Descriptor 2. Remember, file descriptor 0, which is input, file descriptor 1 is output, and then file descriptor 2 is standard error, standard in, standard out, and standard error. Then if it successfully execute or fork the process, okay, then you check whether its PID is equal to 0. If PID equal to 0, that means that's a child process. So at that point, you have two processes executing the same code. What you need to do is, in this case, this demonstration or this sample code is just try to control if is a child process. You want to load the ls command by using execlp. Otherwise, if it's a parent process, which is the process to start the whole application, then you call wait. And then wait no meaning that you wait until any child process to complete before you continue on. So in that case, the parent process will wait until the child process that execute ls-l complete or exit, and then it will continue on and then execute printf child process complete and then exit as 0. So I believe that everyone probably familiar with this sample code of system call. Again, we're not teaching system call. It's just to recall or remind you. And then we talk about operating system structure and operating system feature, that two-way, one through system program, another one through system call. Now, basically, a system call is an API to operating system feature, but it's a general term, okay? That means any operating system could implement system call, and it should provide the same way so that it can protect or it can provide system resource, system operation, execution with more control way. So there are three most common API or system call API that are available in industry. One is Windows API. I think original system call for Windows called Windows 32 API, but I think right now for Windows 10, it could be kind of different name, but also maybe backward compatible with Windows 32 API, because very early version, I mean, in fact, you have processor, CPU start from 8-bit, 16-bit, 32-bit, 64, 128, or, it starts scaled up, okay. Most of whatever the CPU, as you know that it's also provide backward compatible. So nowadays, you can use i9, i7, and all those Intel processor, but it still support x86 kind of whatever instruction code, okay, which is backward compatible. The one that we have covered in CSC 222, we call POSIX API. And POSIX is an IEEE number 10 something, okay, which is industry standard. So in that case, the POSIX API for system call support on various operating systems, okay. That's why I think we choose POSIX API to be API of choice that we cover in the class, okay. But basically, I think all you need to know, okay, all I want you to know is the concept and understand how it works. But in terms of the syntax or API, I think you can just look up and then work or gain experience when you start doing the real work, okay? And last but not least, in terms of system call API, besides Win32 POSIX API, then we have Java API that you can access, some sort of system feature in JVM or Java virtual machine. And most POSIX API support through C or C++ binding. That means in native code, if you want to call system call in Linux, you have to write program in C or C++. However, if you write program in other languages like Python, Java, or other programming language besides C. You can still can call system call, but there are some sort of the bridging tools that you could call, the third language. For example, I think I remember only from Java. I think Java has Java JNI, Java Native Interface, which you also can bridge calling C subroutine or C system call within Java code. Okay, so Google those. I mean, we're not gonna cover everything there, but it's something that you should know this. Now, specific to Linux system call. Basically, there are roughly 60 system call on in Linux. Okay, which classify in categories such as process control, basic I/O, file operation, permission, and system status. Okay, most if not all Linux system call, okay, is written in C. So therefore, to access in most efficient way is just using a straight C or C++ program. If you use other languages, then it's gonna have to go through the bridge, which you're gonna add on some sort of overhead. Okay, so I think that's life. Um, Now, example, of how the system call use. I mean, if you see the pseudocode in the blue box in the middle, okay, when you write, your application, normally, I mean, for example, you may start by acquire the input the file name. So in that case, you can use scanf, and then you can say printf prompt out the screen. Okay, so both scanf and printf, okay, those are a standard IO function, okay, which is not classified as system call. But in fact, I bet that printf or scanf, the internal code by itself, it will make use of some of those system call in the back end. Okay, then you accept the input. Okay, yes or no, same thing as you can use standard input and output function, and then acquire the output file name, write prompt file, and then you can start open file. The open file, pseudo code there. In fact, that is a straight system call that you can use. So I think basically the example of given program, you may have mixture of user regular program with system call there. The thing that I want to call for your attention is that system call, is a special function call that it will impose much more overhead. Okay. However, you cannot avoid those, and the current hardware technology is quite capable. So if you don't excessively call system call so many times, put in the tight loop, therefore you're not going to be penalized by the performance hit. Okay, but however, when you start writing or develop your application, if there are other ways that you don't have to use system call, you can use an equivalent regular function, okay, or user function that perform similar thing, then please don't use system call. Okay, except when there's no choice, you have to use system call. Use system call with mindful. Use system call with consideration in a way that it may also increase overhead, and therefore it gonna kind of compromise your performance or system performance. Okay, now let's take a look at how the system call get implemented. Okay. Mostly system call is a kernel program or a kernel level of program that will be part of the kernel. Okay, some system call or modern system in the past, or the system call or system program or kernel will be delivered in one shot. But nowadays, as a system admin, you can install some sort of kernel module or system call on the fly without bring down the operating system. So there is an ability or mechanism allow you to add, change, delete the system call or system program on the fly. Okay, we'll talk about. I think if we have extra time, I'm gonna talk about kernel programming, device driver programming, and then an ability to add or update the kernel without bringing down the system. Okay, but then all those based on Linux type of environment. Okay, I don't know any other environment like Mac OS or Windows, because they have total control and they would not allow us to access how to see their code. But as I think you all know that Linux is open source, so therefore I believe that, I mean, it's not, I mean, internal working is not much different. Okay, so understand the concept of one system, you can apply the concept to any other system. But assuming that you know how to write kernel program, okay, or the system called develop system call by itself to install it, okay, then you're gonna register the new system call, okay, to operating system. So each system call has number associated with it. Why do we need to have that unique number associated with each system call? For example, if you have originally two devices, okay, that support open, read, and write, okay, and close, okay, maybe first to device number one, and then you have another device that you just install, and then it support open, read, and write, and close, the same operation, okay. Now, as the end user should not have to know the detail of these two devices in more detail. If these two devices are supposed to do the same thing by provide, for example, file management, file, create the file, read and write to a file. And you are the third company that you want to install your new storage device, but then support the same operation, read, write, open, read, write, and close, okay. So in that case, each of the device vendor would has their own system call or kernel modules that implement this system call. And then once you install, I'm not sure how many of you guys have installed some new hardware, and then you have to download, or it's automatically download, the add-on or whatever the modules or device driver module, into your kernel. So in fact, during the download and installation, it will register the set of system call that pertaining to that device, to the system table, and then register with the unique number. So that once you open the certain device or device driver, then the operating system know what this particular open executable that map to based on those numbers, and then it will call that appropriately, okay. This is how this thing works. So I hope you understand high level concept, but once we have time, I think my budget is I would cover this chapter 2 and then continue four chapter that related to process and thread, and then I will cover memory management, file management, and then if we have time, okay. Normally I think I plan to have presentation of you guys, and so many of you guys, initially I thought that I probably would not have time, but then with this online or live stream delivery or class delivery, we might have some time to cover kernel programming, device driver, and whatever those kernel module installation, okay. So those are for advanced user. Some of those, in fact, when I was student, I studied in advanced operating system class. So I think if you have time, I can offer part of whatever the extra material to this class, okay. So I think basically, I think the system call implementation is written in kernel program, which is in C. And as you know that, for example, if you want to print out to the screen, normally you use printf, but then once you do kernel modules or system call, you cannot use printf. If you want to prompt certain information, okay, so then the user would know what's going on there. There is no such thing like printf things there. You have to use printk. And now printk you will not see from your standard output. So you have to find the right location in order to inspect and see what's going on there. So we'll touch upon some of those things, okay. And now a lot of these system call, they look similar, but the implementation of each system call may be different based upon the way you communicate to underlying hardware. Let's say if you have hard drive, which is regular hard drive versus SSD, underneath hardware is different. But then as the user or end user, when I want to read and write the file to either regular hard drive or SSD, I don't care. All I need to do is just open, read, and write. But then the developer of the device driver for the company that support like the Seagate, that support the regular hard drive versus SSD, okay, then you have to have your own set of the system call implementation, how to access underlying hardware. Okay, so those are the concept of system call implementation that in short I want you to kind of get an overall ideas. Okay, but all the detail, I hope that if we have time, I'll give you some sample code or whatever exercise. You should be able to figure this thing out. It's not that difficult, but it's also not easy. And normally it's not being taught in regular operating system. Okay, so as I told you, take crisis to be opportunities, guy. You know, um, I think um, one guy has asked question about Carrick asked about what does f printf does. Okay, Carrick, f printf is similar to printf. You remember printf? Printf will print the format output with a conversion specification like percent sign %s, percent sign %d, percent sign something, but then it only channel to standard output. And the f in front of printf, okay, suggests that you can print to any file descriptor. So therefore, the first argument would be file descriptor. It could be regular file that you open, and then you can pass that file descriptor, I mean, from the open, I mean, as the first argument to fprintf. However, if you do fprintf and then the first argument as standard out, it's going to be similar to printf. Or if you put standard error as the first argument to fprintf, instead of it print all those messages to standard output, it's going to print to standard error. So I hope I think this explain and recall what we have discussed in 222. And if you guys who not taking 222 with me, I hope, I mean, you follow me. Please ask any question. No question is silly question. Okay, sometimes, you know, I mean, you forget something. All right. Okay. So Tim, I like you call me a big cat bros. Okay. So cool. All right. Let's continue on. This is a diagram show how system call work. Okay, as I told you, this is very important. You know, in the future when you start design an application or the system that has the mixture of system call or regular program or regular instruction. You know, regular instruction will execute at the user mode. If you see on the top, you know, I mean that you have the line marked in between user mode and kernel mode. All those regular instructions, for example, when you define variable a in a equal b, or a equal to b plus c, those will be executed at user mode. So therefore, the execution of user mode is going to be at the speed of CPU on each instruction. So if your CPU is 3.6 gigahertz, then each instruction will execute at 6 gigahertz. There's no overhead. However, if you make a system call, okay, for example, open there, then your user application process, when it make the open call, okay, which is system call, then it will get suspended. And then the protection mechanism user mode to kernel mode, which is the bit mode that implement in the hardware, would flip from user to kernel, and then user will be suspended, and then the kernel would take over and start looking into the number. Remember I mentioned about the number that represent a specific system call for specific device. Okay, that will, the call will be made while the system or user application gets suspended or put into sleep. And then the execution will get start all the way to complete, and once it return, then it will wake up the user process and then hand back the control and resume the process, user application process execution. Now you guys remember how operating system remember where to resume, which instruction to resume. What is the data structure or data element that operating system used to remember? You got to remember PCB, process control block, which we're going to talk about it in chapter 3 when we talk about process management. You got to remember program counter. Well, program counter is a placeholder that store the current instruction that when the process gets suspended, when it resume execution, it will execute from that PC and continue on to the next address. Okay, so this is a diagram showing how the system call work, and then therefore you can see that there are much more overhead. What's overhead that system call will be much more add on the top of regular user instruction. One is flipping the mode from user to kernel. One is transfer control from user to kernel. One is to look up which of the system call number and then get execute. One overhead is include put the process to sleep. What is put the process to sleep? So in that case, operating system have to save the process state into PCB. Okay, and then once everything done, then the operating system has to wake up the process and then restore all those process status or information back to the process and then resume that execution. You can see that if the system call is very small or tiny, but then you can have a lot of overhead on the top of that call. So therefore, as I told you, if it's not necessary to do system call, you have some equivalent user function to perform similarly, then don't do system call. Because if you put in a tight loop like 100,000 or million, you're gonna kill the performance of the system. I hope you guys get this one because I keep repeating myself, and then there are some of our colleagues in this class didn't have previous class with me, so that's why I'm kind of keep emphasize on this important aspect. Trust me, because I think some of you guys who took class with me, I used to be a solution architect for AT&T, or the technical lead that responsible for an overall product in any technical aspect, including feature, performance, and everything. So some of these are very critical, when you start deploy your application, because when you slow things down, I mean, especially when you have application that being used by million of user or million of subscriber, that huge. Okay, all right, let's move on. Now, I think this is just showing you, as I told you, the printf, which is standard libraries, okay, or standard IO libraries, okay. It appear that it's just like regular function call, but in fact, some of standard library is make use of system call, okay. So in this case, printf, it underneath it or below. In terms of implementation of printf, in fact, it called write system call underneath. So therefore, you can have an effect of the system call or overhead. Okay, that will include into an overall things. Okay, so I think this is just to show you it's not only the regular system call, but also some standard library that implement by using some system call. You can have the same effect there. Now, I think this is in case that if you are system call developers, okay, sometimes you have to pass parameter to those system call. So there are three methodologies in which you can pass parameter to system call, which is like a special function call. You got to remember when you write C program, I mean, sometimes your function, you may pass parameter, and then passing parameter, you have call by value or call by reference, okay. That's something that's quite important concept in programming language, okay. So I think you can go back and recall those concepts. Similarly, the system call, I mean, some system call require parameter passing. So generally, there are three methods of passing parameter from user mode to OS mode. Okay, the simplest way is passing the straight simple parameter and copy to register. Okay, so in that case, it will support one or not many parameters. Okay, because you also can save or put the address of the data into register and then tell operating system and go read from data from that address. Okay. The second method, okay, instead of using register, you also can store the block or the table in the memory. And then, but the first method is just simple value. So you can copy the value of parameter into register. The second method is passing the address to that block or the table in memory, okay, into register, so that you can pass as many parameters as you wish. But in that case, I mean, you have to know how to decode or extract portion of the block of memory or that table, so that you know that the first parameter is integer, second parameter is string, third parameter is whatnot, okay. And then last but not least method is using stack concept. You can push and pop whatever parameter. When you pass parameter, just push into stack. And if you pass 3 parameter, then push 3 item into the stack, okay. And then each item could be just like a straight data, integer, floating point, or whatnot, or it could be an address that is pushed to the stack, and then allow the operating system to pop the stack and access those data, okay. So this is a basic kind of idea or concept how passing parameter to system call from user program as system call developers, okay. So I think this diagram showing, I mean, uh, the first or second approach. If the first approach, then you just pass or you just copy the value of parameter into register. Or if you use second approach by passing a pointer to the table or to the block, then you can pass the starting address of that block or table where that given register X there. So then the system call could access the data and then call appropriate system call. And in this case, I think we just show example that it happened to be system call number 30. All right. Okay. So I think this is just some idea how the system call works to implement. As I mentioned to you before, we cover system call extensively, especially on Linux. Okay, on lecture 5 in CSC 222. I'm not sure for people who has not taken class with me. Why don't I do this? I'll post and then I will label it clearly that this is CSC lecture 5 on Moodle. So in the case that if someone has not taken class with me, you should be able to access. If you take from Abdullah or someone, I don't know whether what they use, but all these guide, I have given all my lecture note to them all, okay. So I think their choice to use my lecture or not, or even the homework, they have liberty to giving you whatever they think is the best for you. So obviously they didn't ask you to do the shell program, I think with some reason. But anyhow, I will post the lecture 5 from CSC 222 that we discussed system call quite extensively. So in that case, I mean, for someone who has taken class with me, you should be able to access, or you should reuse whatever I have there. Otherwise, for someone who has not taken 222 with me, you can access, I mean, my lecture here. All right. So let me do a quick check to see whether anyone asked some question on can you print to standard in carrying that doesn't, I mean, it the operation does not make sense, just like, can you read some data from your printer, because printer is an output kind of device, right? So in that case, you should send something, the same thing or the same metaphor as printf. You print to standard out or standard error or to a file. To standard in that device, I think if you implement your keyboard that has a two-way protocol that can take some input, for example, normally when you use your keyboard, it's as an input device, right? But then, I mean, some maybe smart keyboard in the future, you can reconfigure them. So in that case, maybe if you implement your own device driver, okay, then it may take standard in as well, But in general, printf will not, I mean, you should not print to standard in, okay. By the way, this answer is based on some question that I saw from the live chat, okay. So please do so. Yeah, so fprintf is normally for standard out, standard error, and also file descriptor. Because if you do file open or open file name, open will return file descriptor, which is in the by nature is similar or the same classification of the standard out or standard error, or the standard in, standard out, or standard error is a well-known file descriptor number, okay, that being predefined as 0, 1, and 2. And then, normal file descriptor, it will auto generate by the system. So in that case, fprintf could also, you can pass a file descriptor as the first argument. So I hope I answer your question. Good job. Thanks for asking. Okay. All right. So now we finish system call. Now we continue to system programs. Okay. Um, well, initially I was hesitant to go through some of these details because we cover extensively in our CSC 222 in chapter. In fact, some chapter 2 we talk about Linux kind of thing. But I think I don't want to make assumption that we all know the same thing. And then the first class, I think I did a quick survey. I saw a lot of hand raising that who didn't have 222 with me. So bear with me for people who has 222 with me. If it's slow, then just kind of pace along with me, sip some coffee. I mean, at least you sit comfortably. I don't know, either on your couch or on your bed. Okay, so but anyhow, in terms of system program, it offers a similar feature that the system call provides, including file manipulation or file management, status information, file modification, programming language support, compile the program, link the program, some runtime, or uh, um, static library, the dynamic library that you can include during runtime or during execution time. You are the Microsoft programmer. You have DDE, dynamic link and load kind of environments, okay, or different kind of thing. And then beside that, it also allow you to load, execute the program. Those are process management, communication, and various application program, including editor. I think you guys use either VI, Nano, Emacs, or whatnot. Okay, so it's a variety of system program that operating system provide, so that it would give user convenient to access a various feature from the system. But basically, these are two parallel kind of approach that system program, system call provide similar services, okay, to operating system. Okay, I think this is more detail. How each of those category, provide our system program provide convenient environment to execute, similar to those system call. File manipulation allow you to do create, delete, copy, rename, print, dump, list, link. You can remember link, soft link, and hard link. We talk about those ln command. The link command is used for create an alias to a file. So if you guys are not familiar, let me just quickly demonstrate or show you this. Okay, so let me switch to the terminal and then show you. Say that I have this file. Okay, pt1.c, pt2.c, pt3.c, and pt4.c. Beside, you can create directory by say mkdir test. Okay, these are the file manipulation, or you can create a new file by say touch test.new. I mean, there are various programs. You can edit the file, or you can use touch, which is create 0 by file. Okay, if the file does not exist, when you say touch that file, when you hit enter, when you let me see. Oh, I misspelled touch. Touch. I'm sorry. Touch. Touch. And then when I say ls-l, you can see that I create a new file called touch, and then the timestamp is the current timestamp. So I think there are various system program that or system application that allow you to do certain thing. I mean now what I'm try to demonstrate to you is the program or system program that allow you to create a directory, create file. Now, I think for someone who has not has class with me, I'm not sure your instructor talk about ln command or not. When you use ln, okay, for example, if I do ln and then a dot out, okay, and then so ln is a system program or utility that allow you to create another file name that attach to the same file structure. What do I mean by that? That means, let's say if you have one file, but you want to create two names. Okay, why someone want to create different name? Well, maybe you want to set permission on different name, and so that you can provide access to your colleagues, okay? And then you don't want to give the real name of the file, okay, for certain whatever reason. So in that case, you can use ln command to do ln original file and then the new file name, okay? So I will call the second file name is a1.out, okay? So in this case, if you use ln command, it's gonna create a hard link, okay? So when I hit enter, now when I say ls-l, you will see that a.out and a.out, a1.out, it look identical. But in fact, it point to the same storage. But what it does in terms of hard link, it create a file header, two file headers, okay, that point to the same storage. So in that case, I can either delete a1.out or a.out. I still have my files there, okay? But then if I want to completely delete them all, then I have to delete two files, okay? Because when I delete, first I delete only file header. If you have only one file header, so therefore the original file is gone. But in fact, the actual storage is still there. That's why I'm not sure how many of you guys had make mistake and you use this utility to recover the deleted file, because the actual file system, normally when you say delete, it does not do deep delete. It does not go and shred all the data, because it's gonna take much more time. It just mark that, okay, this location that store for this file is free now, you can use it, okay, and then you can start marking the beginning or the end, okay, so that in fact you have the data still there. If you have not used or take those space that previously used for another files, okay, that you delete, you can recover that file, okay? So I think coming back to ln, okay, ln command is create a hard link by create two file header point to the same location. What if I want to create a soft link? Soft link is different than hard link. Soft link is you just create the new name or alias name without create the whole file header structure. So in this case, I can use ls-s, which is indicate soft link, a.out, and then I'll call the new file name with a2.out. So in this case, when I do ls, you can see that a2.out is point to a.out, which has only 5 whatever byte storage there, and that 5 byte is just only the file name that point to the same file header, which is a.out, okay? So I hope you get some idea about one utility called ln, which is may not directly related to whatever this operating system structure, but we talk about file manipulation, and I think Linux provide you variety of file manipulation there. Okay, so now let's come back to our lecture here. Any question? Let me just take a quick peek on this one. Okay, so to see anyone provide any comments. Okay, now let's move on. Okay, so now so there are various system programs that provide similar kind of feature to system call, including file management that we already discussed, and then give you example of various things, okay, and then status information. For example, you can type date, time to see what is the current time. looking into performance using top command, SAR command, monitor the system, retrieve certain configuration information, and then see whatever the network port or whatnot. Okay, and then you have all other utility or system programs such as text editor, the command to search for content. You can remember grep command, you can use file command. Remember we talk about those things. And then you have programming language support, compiler, debugger, the Python interpreter, program loader or execution, and then the communication that you can do various things there. Okay, so as I mentioned you before, here you have variety of system nowadays. In the past we just have just computer, but now everything can be tiny computer, can be very large computer. So it somewhat have some sort of system program called operating system to manage and provide ability to provide user interface or control all those resources. Okay, I think next time I would stop at this point. So as I try to kind of motivate you or show you, I think when we come back we're gonna show you this diagram to you again. What I'm trying to say is that there are a variety of systems that has different needs, different requirements. So therefore, it's not one size fit all. But basically, the overall design structure would be layer approach, okay, or ring approach, in which it in fact it gives you ability to break down big problem into smaller problem to be modular. In fact, if you guys heard about agile development, which is just get popularity in the past 5 to 10 years. Okay, in fact, this layer approach has been introduced many years ago. Okay, so when we come back next time, we're gonna talk more about whatever the operating system design and implementation. As I mentioned, it's not one size fit all. All right, so guys, I thanks for your attention, and I gonna call or complete our lecture today. I hope let's do this. Let's try to call your friend and make sure that we have more viewer. Today we have 22, which is I'm quite happy, I will soon. I would try to do some sort of homework on how to make the quiz and provide that quiz to you, because quiz will tell me whether you follow me or not. Okay, so I want to make sure that you have we have maximized your learning experience, even though in this challenge kind of situation, stay away from people. I think all they said that to win against this virus is not spreading the virus. So therefore, if we make sure that we don't go and get this contact to others, hang on for a few weeks, 1 or 2 weeks, this is gonna die down and we are gonna be come back to normalcy. Okay, so with that, you can send me email, add my Skype. You want to talk to me, asking me some question, feel free. I'll try to be available 1:30 to 3:30 every day. Okay, otherwise I thanks you for wake up early and be together here. So be safe and take care everyone, and see you this coming whatever class, which is what next Tuesday. All right, okay, so thank you guys. Talk to you later. Bye.